We're going to go ahead and get started. So first off, hope everyone is having a great evening. Hope you've had a nice week so far, and you're here for our next planetarium live stream. So my name is Krista. For those of you, you may have seen me at the planetarium before. I am going to be presenting today talking about the future of human spaceflight. So this is a particularly interesting topic considering the landing that we just had on Mars not too long ago. So we'll definitely be talking about that along with the plans for the next astronauts to get to the moon, and some other companies and what they're planning on doing with regards to humans getting out into space. So a few housekeeping things before we get started. If you do want to leave any comments, so during the show today, and you may know this if you've joined us before, but if this is your first live stream with us, if you'd like to leave any comments, just make sure that you like our Facebook page, and that'll allow you to leave comments, and you can ask questions in the chat there. That is a great way, both during the show. We do have some other of our planetarium educators here with us. So I have Mike and Andrew in the chat. And if you have any questions during the program, you can enter those in the chat, leave a comment, and they will do their best to answer as many as possible. So if you do ask a question, keep your eye out in that chat because they may answer it, or every so often during the show, probably at the very end when we have time, I'll be able to maybe go back and answer a couple questions live. So if you do want to leave any questions or comments, just make sure you go ahead and like our Liberty Science Facebook page. Also, if you do want to donate to our Science Center, thank you so much. First of all, we really love having the support of all of our amazing viewers. To do that, you just need to click the donate button. You do not need to follow any kind of links that get put in the chat. So just all you need to do for that is to click on that donate button. We are open every weekend, Thursday through Sunday, so if you would like to come and see me or Mike or Andrew in the planetarium, we are there every weekend. We've got shows going every hour, so lots of different kinds of shows there. You can check us out on our website. And this coming spring break period, we do have some exciting things coming up, so just make sure you keep following us or checking us out on social media, and we'll be posting some of the exciting events that we have to come. All right, so with all of that out of the way, I am gonna go ahead now and get us started with our show. So like I mentioned, we are going to be talking all about human travel back into space. So there has been one place so far that human beings have gone to, and that is, of course, our closest neighbor, the moon. So the next time that you're able to see the moon in the nighttime sky, and it's great, it's one of the objects that you can see just fine with your bare eyes, and take a look out there and just imagine that there have been human beings walking on that object, just up there in the sky. Now, they have not been back there since the 70s, but that's okay. It's kind of the goal that I'm going to be telling you about, is to try and get people back to the moon. So back in 1968 was the first crew that flew to the moon, and then the first moon landing happened on 1969. So if we want to pretend that we took off from the Science Center, that would be pretty great if we had a rocket ship take off from the Science Center to fly to the moon. But if we were able to, or you can just imagine it from Earth, a rocket ship taking off and flying humans about 240,000 miles away to go and visit our closest neighbor. It took about 3 days for those flights to occur. Now, our moon is definitely smaller, and it looks a lot different from our planet. So the moon, you can fit about 50 moons or so inside the Earth. It is covered in all of these awesome craters. And part of what we want to do, and what previous missions sending astronauts to the moon, is to try and learn how these craters formed. What is the moon made of? What's going on underneath the crust of the moon? Is there any evidence of water or of life? So these are many questions that we have been trying to answer for decades now. So I'm going to put up landing sites of the previous Apollo missions, so different areas on the moon where humans have touched down and walked on the moon. Now, I don't need to continue rotating around the moon here because all of the moon landings have been on this one side of the moon, which is the side that faces us. So it does turn out that the moon, even though the moon does spin, it does rotate like the Earth, but it rotates at the exact same speed that it revolves around the Earth. So because of that, we always see one side of the moon from here on the ground. And it's much easier for us to communicate with astronauts. So if you imagine you all are on Earth, and my face is the moon, having an astronaut land on the part that's facing you, it's much easier to have communication be sent from this side of the moon to the Earth versus behind me having to get some communication to travel all the way around my head to get back to Earth. So all of the humans so far, we've landed, you may have heard China landed a lander on the far side of the moon, but no people have gone there so far. But of all of the human landings, all the Apollo missions that have gone onto the moon, they haven't been back since 1972. That was the last moon landing. But there have been quite a few people that have traveled to the moon. So I'll just show you here. So we've had 24 astronauts that have flown to the moon. I know my face is kind of in the way. I'll try to move out so you can see the two here. So we've had 24 astronauts that have flown to the moon. Only 12 of them, though, have walked on the surface. So not every astronaut that flies to the moon get to leave the spacecraft and walk on the surface. Some of them orbit around the moon as their fellow astronauts touch down on the surface, and some of them have to stay inside the shuttle to take care of different experiments and different important things, make sure the shuttle stays safe and running while the others walk on the surface. Still a very important job, and then again we'll be adding to this number soon. And I do want to ask if you notice a theme here that these are all men. So one of the next goals of getting humans back to the moon is we definitely want to send the next woman to the moon as well. So that's going to be very exciting. So this mission that I've kind of been alluding to is something called the Artemis Mission. So this is a NASA-based mission to get, again, the next humans to the moon. They're trying to make it a more sustainable course, which means make it a lot better for the environment, make it easier to get people from the surface of the Earth all the way out to that 240,000 mile away moon. We want to make this as efficient as possible. And then again, we want to get the next humans landed on the surface, and we want to have the moon become kind of like a stepping stone to getting humans or other missions even farther away. So we think about our moon being the closest neighbor, but being 240,000 miles away, and that's our closest neighbor, it is still difficult to get there. So having a stepping stone at that first little stop at our closest neighbor is a lot more helpful to continuing on after that. So this might even be an idea as kind of like a pit stop on our trips to future. Now, the Artemis mission is going to kind of be in 3 stages. So the goal is to try and get humans to land in 2024. So that may change. It might become delayed as we get more and more things working, but that's kind of one of the goal dates right now. We're trying to plan for that, but things happen. And to lead up to this, so Artemis is basically going to have one stage first that'll have an uncrewed mission, so just a rocket ship, so we can test out all the necessary parts and vehicles getting people to the moon. Then there will be a second phase of the Artemis mission, which is going to send humans on their furthest distance ever from Earth. So they're going to go actually farther than the moon, and just to kind of test out getting humans into deep space travel, which is one of the very future goals for having humans travel in space. So that's going to be the second phase. That'll be a 10-day trip. And then there'll be the third phase of the Artemis mission, which will be astronauts traveling to the moon. And that's the goal to have in 2024. And again, keep your eye out in Space News, keep your eye out with us. We will try to keep you as updated as we can for future missions and as these things get updated. So here is the crew of the Artemis mission. Now, not all of these may be the ones to travel to the moon, and I'll talk about that in a minute, but in the future, the Artemis mission and NASA will announce which astronauts will be the first ones to go on these different phases of the mission. But this is the pool of astronauts that they will be selected from. You can actually find some of them on social media. So I follow a couple of these astronauts on Instagram, and it helps me keep an idea and keep track of how they're training and what kind of things that they're learning. So I'm going to talk a little bit about what the mission is going to look like. How are we getting humans to the moon? So I'm going to pause it right about here. So there are different parts to this whole process of this whole entire rocket ship. It's kind of divided into different parts to try and get humans safely from the ground up to the moon. So what you're seeing here is something called the Orion capsule. This is where the astronauts are basically going to be during that 3-day trip up to the moon, about 3 days. And yes, it's not that big. It's quite a small space, and part of that is because the more space there is on this rocket, that means the more weight it is and the more fuel is needed to get people up there. And again, we're trying to make this as sustainable as possible, so this is a pretty compact size. And you'll notice that it only fits about 4 people in there. So only about 4 astronauts, or up to 4, are going to be going on this trip. Now, there are other parts of the Orion capsule. So below it, you have the service module that has all the things that the astronauts will need: oxygen, things to keep them at the right temperature, extra fuel. All that stuff will be kind of below them. And then there's also a safety feature here that if anything happens to go wrong during the launch, there is a launch abort system here with its own rockets near the top that can actually take the crew off of the big rocket that I'm about to show you and get them to safety. So it's kind of a safety feature here to make sure that the astronauts can remain safe. So that's kind of the whole part of getting the astronauts themselves up to the moon. And then we have the part that is going to launch them off of Earth. So everything else you see here, let me go back just a second. Everything else you see here, try to pause it at exactly the right spot. This whole thing is called the Space Launch System. So basically another name you can think for that is the rocket ship that's going to get the astronauts off the ground and out into space. So there is a cargo hold, so that has all stuff that's needed for storage there. And then there's a couple different stages that are going to come into play during this whole takeoff. So when this is built, this is actually going to be the most powerful rocket in the world. So this is very exciting, and that's why it's taking kind of a while to make sure we get it perfected and everything works just fine. So this rocket ship basically has 5.2 million pounds of fuel in it. The whole rocket itself weighs about 6 million pounds. So most of its fuel trying to make sure we can launch everything off of the surface of the Earth, right? We have to go pretty fast to escape Earth's gravity and ensure that we get out there. So I'm going to pause just in case you might have noticed that there were rockets that kind of fell off. So at different stages, we'll have some of those booster rockets separate from the main rocket because they're no longer needed. And then eventually we end up with just that Orion capsule that has the astronauts living inside of it and then the necessary things to keep them safe. After a certain point of launch, it's just going to be coasting out to the moon. So at this point where I paused it, this Orion capsule is basically just floating towards the moon. There's no more rockets, anything like that, boosting the capsule. It is just floating out to the moon. And what makes this Artemis mission kind of different from the missions that have been happening previously, so from those Apollo missions, before, back in the 60s and 70s, the Apollo missions needed to have every single thing inside of their rocket. Everything needed, all the experiments, all the tools, any rovers they wanted, everything had to be on that rocket that traveled to the moon. So Artemis, again, in a way to make this more sustainable, more easy to make multiple trips to the moon, we're actually going to try and get all of those necessary things on the moon before the astronauts get there. So working with other international companies and other organizations, we're going to try to get rovers, experiments, all the equipment that's needed landed on the moon already in advance, so they won't have to be put into that rocket ship with the astronauts. So hopefully that'll all be prepared. And in the future, maybe not for this first time we get astronauts to the moon, but another really cool plan for the Artemis mission is to have another piece of technology called Gateway. So I know it kind of looks like the International Space Station here, and that's kind of what it is, but it's more like the Moon Space Station. So the plan for Gateway, which is, again, this thing orbiting around, it's going to cover more surface area of the moon than the previous Apollo missions. So it'll help us both study the moon as we're orbiting around it, and it's going to help to launch different things down to the surface of the moon at different angles, and we'll be able to explore more of the moon much better than the previous missions. So in the future, basically what will happen when the Apollo or the Orion spacecraft gets to the moon, it's going to be in an exact right spot to attach to that gateway, and then any astronauts that are pre-selected to actually go down onto the surface of the moon will board the lander. The lander will take off from Gateway and touch right down onto the surface. So you'll notice a lot of this is actually kind of exact matching. A ton of math and physics goes into these missions out into space. And that's because we can't rely on using up all of our fuel and all of our gas to have rockets boosting and going all over the place. If we line everything up exactly right, then all of this can be done just by floating and exact angles and measurements. So a ton of math and engineering goes into these types of missions. So again, we'll have those pre-selected astronauts. They will land onto the surface, do what they need to do, different experiments, and use that technology that was already placed on the surface of the moon. And then when they're done, they will board back onto the lander. It'll take off and come right back up to Gateway, which has just been orbiting around the moon. You can think of Gateway like a subway system. It has just been going around and waiting for more and more people to come. And that's kind of a really cool thing about Gateway, is it actually has multiple ports here. You can think of it like a power strip. So we can actually have astronauts doing multiple missions. So not even just from the US, we can have missions from different countries even come and use Gateway, and a bunch of astronauts can be aboard this place at the same time, working together and helping to, again, make this more sustainable, getting people here to learn about our moon and to do even more. So after this mission is done, the astronauts get ready to go home. They'll basically take back off from Gateway in their Orion capsule, fly back to Earth on that 3-ish day trip. By the time that the Orion capsule gets back into the Earth's atmosphere, it is going 25,000 miles an hour as it's coming back into our atmosphere. You can see how hot it is getting, so this capsule does have a very important heat shield to make sure the astronauts are safe as they're re-entering our atmosphere. And then eventually, once it gets down to a certain distance, there are parachutes that will open up and basically slow the capsule down until it is going 25 miles an hour, much better speed, so that lander can touch back down into the water nice and safe back here on Earth. So I'm just going to show a couple things if you want to learn more about the rocket. Again, this space launch system that's going to be taking the astronauts up to the moon. You can see just some comparisons here. It is going to be the most powerful rocket in the world, even more powerful than that Saturn V rocket, which at this point has been the most powerful one. It's basically almost as tall, or actually a little taller than the Statue of Liberty. So this is a big rocket here, and we need it to, again, be able to get those astronauts off the ground and up to the moon. So kind of needs to be super powerful. Before I keep talking about the moon too, I do want to just point out that this, again, is kind of a stepping stone, right, of getting humans to the moon, and then eventually, hopefully, this will help us learn how to keep astronauts safe in space, living there for longer periods of time, and figuring out if we can get people to the moon. Maybe that will be a nice, easy step to getting us then to travel to Mars. And even so, after that, we can get not necessarily humans, but maybe this can help us figure out how to get robots. Once we have maybe a base or a stepping stone on the moon, and maybe even Mars, that will be much easier for us to then send other missions, robotic missions, that have been refueled out to other planets that are further away. So places like Jupiter, to study Europa, which is a moon that has an ocean underneath its icy crust. So this could actually help us more easily study these worlds out in our solar system and try to figure out, is there life somewhere else, or could we maybe live there in the future? So this is all really exciting stuff, starting with getting humans back to the moon, hopefully in 2024. So just going to kind of show again another view of this rocket. So again, this is the Orion capsule. If you want to kind of see it in real life, the 4 astronauts sit up in this part here. So the capsule itself, again, it's pretty small, especially when you compare it to the giant rocket that's going to be taking off. And then here is an image of a model of what that gateway will look like. And again, you'll have the landers and the Orion capsule attaching to gateway to go down to the surface of the moon. So really exciting stuff that we have to look forward to. Now, of course, when the astronauts are down on the surface of the moon, we want to keep them safe too. So there are also plans for creating new spacesuits. So the new spacesuits can actually have up to 16 layers of material to both keep the astronauts safe, right? Give them a source of oxygen so they can breathe, also keep their temperatures regulated. We don't want them to overheat, but we don't want them to be too cold. The moon has no atmosphere, so it is really cold on the surface, so we want to make sure that they're warm enough, but not too warm. So we want to keep them safe. Also, it's including ways for the astronauts to communicate with each other, and even have some tools to help them do experiments more easily as they are walking around and being mobile on the surface of the moon. Some new ideas for that too. And since I've kind of been talking about life and maybe having humans living on the surface of the moon, one of the major ideas once we get there, once the astronauts actually get back to the surface of the moon, we're actually planning to also study the South Pole of the moon. So that's where I've flown us to here. There is a rover called Viper that's going to be traveling. It's going to drive down to the South Pole of the moon, and it's actually going to be looking for water. So we know there is a concentration of frozen water on the moon. What we're looking at here is the South Pole of the moon. All the bright blue dots are areas where water has been detected, frozen water. And then on the right, that is the North Pole. So we've definitely seen more water at the South Pole, which is why we're sending that rover down there. And we're basically going to learn about the potential for taking some of that water and using it for humans to drink. There's a way to potentially also use the oxygen of that water and make it into rocket fuel for both sending things back to Earth and then sending things onward to study more of the places out there in the solar system. So this is a model of Viper that's going to be, again, driving down to the South Pole and helping us learn about how much and the location of water on the moon. So something that also has not been announced yet, let me make sure just move myself out of the way for a second so you can see here. So there are actually 3 companies that right now are being considered to help design that lander to get humans from the Orion spacecraft down onto the surface of the moon. There are 3 companies, so SpaceX, Dynetics, and Blue Origin. So these are all 3 potential companies. NASA has not chosen which one is going to be. So I mean, taking a look here at these 3 landers, which one do you think looks the most exciting? Which one do you think looks the most practical? Which one do you think looks super weird? Like you were not expecting a lander to look like this. So NASA's basically considering all the aspects of the design from these 3 companies, which one is going to make the most sense for their mission, and then they'll be announcing that decision later on. So that is something that hasn't happened yet, but something we can keep an eye out for to see. So at this point, I'm going to now move on and talk about what else, right? So talked a lot about getting humans to the moon. Well, what about you and me, right? Is there a chance that we will be able to get to go to space anytime soon? So quite a few private companies or I guess other type of organizations, so SpaceX, for example, they are, again, one of the people that might be making a lander for the Artemis mission. They have been involved with commercial flights. So you may have heard from Elon Musk, who's the CEO of SpaceX. He, last year, 2020, he helped to take humans from Earth to the space station. So it was one of the first commercial companies to travel to the space station to get to take astronauts from the ground up to space. And then they also have in the works basically private trips of getting humans up into this higher up area. So kind of what I'm showing you here. SpaceX, along with some other companies too, I'm going to mention another one, have the idea of getting humans into space. So not as far away as the moon yet, not as far away potentially as the International Space Station, but getting humans up technically into space, hundreds of miles above the Earth here in what's called low Earth orbit, which is technically about 1,200 miles or less from the surface of the Earth. So SpaceX does have some plans of getting civilians, which are people that are not in an astronaut, up into these trips to orbit around the Earth in this low Earth orbit. In the future, I've heard things about SpaceX getting plane flights to take you from one country to the next in 25 minutes, which sounds like a huge time saver. That would be really great, right? So it's almost like a spaceship trip from one country to the other. Oh, and I'll go back really quick because in March, SpaceX is actually announcing the crew for the first all-civilian spaceflight. And so that is called Inspiration 4. That is going to have humans basically traveling at the same view of what we're seeing here. They're getting humans the first all-civilian flight in low Earth orbit. And again, that crew is going to be announced this month. So keep an eye out for that as well. This is one of the coolest places. I definitely would like to try and visit this one day. This is something called Spaceport. So it is found in New Mexico. This is a Virgin Galactic company that right now is focusing mainly on private individuals and researchers, getting them flights up in kind of the same level that I was just talking about. It is quite expensive right now to get people up on these flights. So a flight from Spaceport, for example, is something like $250,000 to get you on one of these trips up there. So haven't figured out quite the most sustainable way to get these human trips to space, but that's one of the goals of Virgin Galactic here is to try and make this more sustainable. Like we talked about the space launch system that's taking the Artemis mission up. It's using 5.2 million tons of fuel. So if there's a way for us to maybe make a more sustainable journey up into space, that's kind of one of the things that we're looking into. So definitely some interesting and exciting things coming up with people on space flights. But like I mentioned at the very beginning, one of the most exciting and intriguing questions we get are people going to go to Mars? Are we going to be on Mars one day? So considering that there was just a rover landing there on February 18th, I forgot what month it was, on February 18th, the Perseverance rover did land on the surface of Mars. If I pause real quick here, just looking at Mars, and I can ask you, do you think we could go and live here right now? What do you think? And if you think yes, why do you think yes? And if you think no, we cannot go live there right now, why do you think no? So you can put your ideas in the chat there. You can kind of think about them. You can talk with the people around you. But one of the biggest things is, I mean, looking at Mars here, you'll notice it looks pretty different from Earth. Everything on Mars, I mean, it basically looks like a big orange. It looks like an orange, right? Before we talk about that rover, just the reason it looks reddish orange like this is pretty much because Mars has rusted over. It's gone through oxidation. There's no water on the surface, no liquid water that we've been able to find. There is an idea that maybe there is liquid water underneath the surface. Maybe by the South Pole, we've potentially detected a lake that's about a mile below the surface of Mars. So there's an idea that maybe there's water. You might notice there's some ice up here at the north. There's ice at the South Pole too. It is a mix of frozen water and carbon dioxide. So it's a little hard to separate the water from the carbon dioxide, so that might not be the best source of water for us, but it is potentially a place where there could be life, either now or in the past. So that's another spot we want to search on Mars. It's pretty hard to get to the poles, though, so it's been difficult so far to get any sort of missions. At this point, the best bet for us to have robots land on Mars are on these nice flat areas. So the Perseverance rover landed in basically a big kind of hole in the surface, which we think was a lake, a really big lake or a sea. So basically a space that was filled with water. So the Perseverance rover, among other things, is going to try to help us figure out whether there was water there, whether there was life, which would help us figure out what kind of life, what was Mars like, could we get life back there again in the future. And it's also going to try and help us search underground. There's a drill at the end of its robot arm here. It's going to drill down and look to try and figure out, is there any sign that there might be water underground? And again, water is one of the most important things that we need to live, so having a source of water on Mars would really help us solve that issue. Another thing that people need to live is, you're probably, I hope, doing this right now, you're breathing in and out. So there's no oxygen really on Mars for us to breathe. But this MOXIE instrument right here on the side of the Perseverance rover, it's actually going to be doing an experiment to try and make oxygen from the carbon dioxide atmosphere on Mars. So it will be trying. This is not an easy thing to do, but it's going to try to do that, because if we can produce an atmosphere that we can breathe, again, that's another huge problem that will be solved to make it much easier for humans to go and both travel to and to stay for any period of time on Mars. And again, we talked about people going to the moon takes about 3 days. It takes about 6 months to travel to the moon. So it's a much longer trip to get there. So the less that we can put on a spaceship, the better. So if there's water and oxygen and source of food and all that already on Mars, that'll be less that we need to take with us as we travel there. So, and then of course there'll be a lot of other things. So we'll be looking at the weather on Mars, helping us to learn how Mars behaves. This here is the Jezero crater where Perseverance landed. You can almost see a river that used to be here and flowed into this crater, and we landed Perseverance right in the middle. The reason that we think that Mars does not have water on it anymore is because Mars is about half the size of Earth. So we think that it's not, we know that it's not geologically active. There's no warm core on the inside. There's no magma, lava that's underground. Nothing really is going on in there anymore. We think it used to be. A long time ago, Mars used to be active just like Earth, but because Mars is half the size, we think that interior, the core, cooled down so much faster, and now it's basically just a rock. And when that happens, when a planet is no longer geologically active, there's really nothing to keep its atmosphere there. So no more magnetic field is created, the atmosphere gets really thin, all the water goes away. So that's really what we think happened to Mars in the past. And leaves us with the Mars that we have now. And one of the ideas is, can we maybe get it back to the way it was? And then a lot of you may have heard of this also. Probably the most fun part of the Perseverance mission is a tiny helicopter called Ingenuity. So this is actually going to be the first solo-powered independent flight on any other planet, and this is not super easy to do. Mars's atmosphere is much thinner than Earth, so it's harder to control and have something fly through on this thin atmosphere. And not only is it just kind of fun and helping us learn about the physics of Mars, but this could also lead to the future of how humans and different things travel around the surface. So like I said, it's really hard to get things to get to the poles of the moon to help us look at that water and the frozen carbon dioxide. Well, if we can get these helicopters flying, and then maybe eventually larger ones that could carry astronauts, maybe this could be a much easier way for us to travel more quickly and learn even more about Mars. Because even though it's half the size of Earth, it is still pretty big for us to get there. All right, so I know I talked a lot about getting people to the future. So I'm going to just take a minute. Let me see if there's questions that we haven't answered. If any co-hosts want to highlight any specific questions that might want to answer. I'm seeing a couple things like, when are we going to Mars? That's a great question. We won't really be able to think of a date, I guess, until we even try out humans living on the moon. The moon is a really, really important step to even think about getting humans to anywhere else in the solar system. Considering that the moon is the easiest place for us to get to, it doesn't have a super harsh environment, and it'll be a great way for us to test being able to sustain people with all the different needs that we have for life. So I can't really say when we think Mars will be colonized, but you know, maybe in our lifetime. I don't think that's completely out of the question. It also depends what you mean by colonized. But there's a lot that we have to figure out still, how to get stuff to breathe, how to get a food source sustained, how to keep us at the right temperature, how to get water, all that kind of stuff. But that's why we constantly need more astronomers and more scientists and engineers to help us figure this out. Let's see. All right. I mean, it seems like our my co-hosts here have done a great job answering all of your questions. So, yeah, I mean, I think if you have other questions, feel free to come and see us at the planetarium. I will be there tomorrow if anyone wants to come visit me. But again, we'll be open Thursday through Sunday. We're open on the weekends, and keep an eye out on our social media for the exciting events we have coming up for spring break. I hope you all are staying safe, and I hope you all have a great rest of your day. So thanks so much, everyone.